Hi and welcome back to Free Science Lessons. By the end of this video you should be able to describe what's meant by EZ isomers. You should then be able to use the CIP priority rules for naming EZ isomers. In the last video we looked at cis-trans isomers, and if you haven't watched that video then you need to watch it now. We find cis-trans isomers in alkenes, and I'm showing you an example here. Because the double bond has very restricted rotation, this alkene can exist in two different forms, and we call these the cis and trans isomers. Now, in order to have cis-trans isomerism, the carbon atoms on either side of the double bond must be attached to two different groups, and this is true in the case of this molecule. The left-hand carbon atom is bonded to a hydrogen atom and a bromine atom, and the right-hand carbon atom is bonded to a hydrogen atom and a methyl group. Secondly, at least one of the groups must be the same for both carbon atoms on either side of the double bond. And in the case of this molecule, we can see that the carbon atoms on either side of the double bond are both attached to a hydrogen atom. Now, as well as cis-trans, scientists also use another naming system, and this is called the EZ system. Just like with cis-trans, we start by looking at the group which is the same on the carbon atoms on either side of the double bond. In this case, that's the hydrogen atom. If the group is on the same side of the molecule, then we call this the Z isomer. So cis 1-bromopropene is the Z isomer. And if the group's on the opposite side of the molecule, we call this the E isomer. So trans 1-bromopropene is the E isomer. Okay, now the EZ system has one major advantage over the cis-trans system. Take a look at this molecule. In this case, the carbon atoms on either side of the double bond are attached to four different groups. So we cannot name these isomers using the cis-trans system. However, we can name them using the EZ system. To do that, we use the CIP priority rules. These initials are from the names of the scientists who developed these rules. First, we look at the atoms attached to the carbons on either side of the double bond. The element with the greatest atomic number is given the higher priority. On the left-hand side of the double bond, we have a chlorine atom and a bromine atom. Chlorine has an atomic number of 17, and bromine has an atomic number of 35. So on the left-hand side of the double bond, bromine has the higher priority. On the right-hand side of the double bond, hydrogen has an atomic number of 1, and fluorine has an atomic number of 9. So on the right-hand side of the double bond, fluorine has the higher priority. So now we assign E or Z using the higher priority groups. In the left-hand isomer, the higher priority groups are on opposite sides of the molecule, so this is the E isomer. And in the right-hand isomer, the higher priority groups are on the same side of the molecule, so this is the Z isomer. Okay, take a look at this molecule. Again, the carbon atoms on either side of the double bond have completely different groups. On the left-hand side of the double bond, we have a bromine atom and an iodine atom. Bromine has an atomic number of 35, and iodine has an atomic number of 53. So this means that iodine is the higher priority group. Now on the right-hand side of the double bond, the carbon atom's attached to two atoms of oxygen, and we can see those here. That means that we cannot establish priority based on the oxygen, so we now move to the next atom. If these are different, we can use these to establish priority. In this case we have a hydrogen atom and we have a carbon atom. The atomic number of hydrogen is 1 and the atomic number of carbon is 6. So this means that the group containing carbon has the higher priority. In the left-hand isomer, the higher priority groups are on opposite sides of the molecule, so this is the E isomer. And in the right-hand isomer, the higher priority groups are on the same side of the molecule, so this is the Z isomer. Okay, here's another molecule for you. I'd like you to determine the E and Z isomers, so pause the video now and try this yourself. Okay, on the left-hand side of the double bond, we have a hydrogen atom and a chlorine atom. Hydrogen has an atomic number of 1 and chlorine has an atomic number of 17. This means that chlorine is the higher priority group. On the right-hand side of the double bond, the carbon atom's bonded to two other carbon atoms, so we cannot use these to establish priority. We then have a carbon atom and a nitrogen atom. Carbon has an atomic number of 6 and nitrogen has an atomic number of 7. This means that the nitrogen-containing group has the higher priority. In the left-hand isomer, the higher priority groups are on the same side of the molecule, so this is the Z isomer. And in the right-hand isomer, the higher priority groups are on opposite sides of the molecule, So this is the E isomer. Okay, so hopefully now you can use the EZ naming system.